Okay, so give you some idea here, guys. This is, just finish up. This is exactly what you will see on your unit exam about reactions. Okay, I will give you some that are like these and ask you to balance them, write them in words, and identify. I will give you some that are written in words and ask you to write them in formula form, identify, and balance. And then I will ask you an equal number where you must predict, like question number 7. All right, so understand that this quiz is very much like what you are going to face on the unit exam on October 7th. Okay, so it's coming right up. Okay, just know this is something that you're going to have to practice quite a bit in the next 12 days. Okay, all right, so for number 1, okay, we've got beryllium. Okay, reacts with oxygen, okay, to form beryllium oxide. Okay, so if theirs looks like that, they can get a mark for writing it in words correctly. Okay, there are no half marks. If they got any part of it wrong, they don't get the mark for writing it out in words correctly. Oh yeah, if they wrote reacts with, yeah. But in the future, guys, you can just write plus, okay, an arrow. That's fine. It's a lot shorter. Okay, what type of reaction is this? Element plus element gives compound. Hannah? It's a synthesis reaction. 1 mark for that. Okay, and lastly, I got to balance it. Beryllium's already balanced. I got to start with oxygen. That's unfortunate, but in this case, because it's a small reaction, it'll work out. There's 2 of them over here. Now there are 2 of them over there, but that means I need 2 berylliums here. So if they've got 2, 1, 2, or 2 blank 2, okay, that would be fine for their 3rd mark for that one. Questions on number 1? Okay. Number 2, okay, written out in words is going to be calcium carbonate plus lithium gives lithium carbonate plus calcium. Okay, 1 mark if theirs looks just like that. Okay, or has reacts with and forms and whatever. Okay, type of reaction. Ionic compound reacts with elements. Reaction type is that? Steve? Single replacement. So if they got single replacement or SR, okay, give them a mark for that. Now we got a balance. Right now the thing present in the largest number is lithium. There's 2 on the product side. Now there's 2 on the reactant side, and everything else is hunky-dory. Okay, so if they've got 1, 2, 1, 1, or blank 2, blank, blank, that's fine. Okay, 1 mark for the balancing. Questions on number 2? Okay, number 3. This one catches a lot of people because they forget that iron requires this when they begin to write the reaction in words. Remember that iron is multivalent, okay? And in this case is with oxygen, 1 to 1, that means iron is a +2, okay? So iron 2 oxide reacts with sodium bromide, okay, producing iron 2 bromide, okay, plus sodium oxide. Okay, it must look just like what I have written here for them to get that mark. Again, no half marks. If you give them a half mark, I will simply take it away later, okay, because I'm just that kind of person. All right, Cameron. Oh, but is it there? It's fine. Okay. Now, what kind of reaction is that? 2 ionic compounds reacting to make 2 new ionic compounds. Andres. Double replacement for 1 mark. Okay, then we got a balance. I could start with either sodium or bromine. It won't matter which because the end result is me putting a 2 here and then stopping because that's the end of it. Okay, so 1, 2, 1, 1, or blank 2, blank, blank, okay, is fine for 3 marks there. Questions on number 3? Okay, now, as I was saying while you were writing, okay, I did notice that when you were given the reaction in words, we forgot to do swapping and dropping a little more, okay, than we usually do. And the one that happened most on is actually number 6. okay, where I saw it happen the most. Right, but for number 4, we have copper 2 nitride. So that means 2 plus here. Nitride is -3, so we got Cu3N2. Okay, breaks down into nitrogen gas, which is special. Okay, it's one of our special elements. Okay, and copper, which is not special. All right. So now I've got to balance this reaction. So sorry, if they have that written out, it has to look just like this. I mean, copper could come first. If they wrote copper first, that's fine. Okay, but they got to have the same numbers that I have. Okay, that's 1 mark. Okay, balancing it, I've got 3 coppers on this side and only 1 over here. So a 3 right there will pretty much balance everything else. Okay, because nitrogen's 2 and 2. Say that again. Right. Here? The little 3?
No, he's saying that like the US if they don't write it. Yeah, that's okay.
Okay, hang on. I gotta come have a look. Okay. So we got the balancing is done. Okay, written in formula form is done. So that's 1 mark for each of those. And then the reaction type. Well, as soon as you see breaks down, you know it is a decomposition reaction. So 1 mark for decomp. Okay. Questions on that one? Okay. This one's reaction type ought to be a dead giveaway with that word in there. Burns would mean it is a combustion reaction. So if they have combustion written somewhere, you can give them a mark for that. Okay, 1 mark for combustion. Okay, and writing it out in formula form is a little easier because I gave you one of the formulas. Okay, reacts with oxygen gas, O2, must be O2. Okay, and that makes carbon dioxide and water. So if their reaction looks like that, they get another mark. Now we got to balance. Special combustion balancing rules are balance alphabetically and the rule of 2. Which one does not apply here? Rule of 2 does not apply here. All right, so C7. All right, 7 there. 16 hydrogens. 8 times 2 is 16. 7 times 2 oxygens is 14, plus 8 more is 22. 11 times 2 is 22. That's what it should look like. Okay, either blank 1178 or 1 1178. Okay. Questions on that one? All right. For number 6, potassium permanganate, KMNO4, reacts with magnesium hydroxide. Here's the one people didn't have swapped and dropped correctly. Okay. This is +1 and this one's -1, so that was fine. People had that one fine. This is 2 plus, this is -1. That's got to be MgOH2, and they must have the brackets. Okay, I saw it written like this on several sheets. That is not the same thing. That is 1 magnesium atom, 1 oxygen atom, and 2 hydrogen atoms. This is 1 magnesium atom, 2 oxygen atoms, and 2 hydrogen atoms. They are different. Okay, and that way is the correct way. All right. Now that will be, because it's 2 ionic compounds for 1 mark, a double replacement reaction. Okay, our new compounds on the other side will be KOH and MgMnO4. Okay, now I've got to swap and drop these. This one's fine because they're 1 and 1, but this one will require brackets and a 2 because this is -1 and this is +2. Okay, everyone with me there? All right, now I got a balance. So I'm going to start with manganate, okay, with permanganate here. All right, there's 2 over there, but only 1 over here, so I'm going to put a 2 there. When I do that, that gives me 2 potassiums. So I put a 2 here to balance them. That gives me 2 hydroxides. There are 2 over here, so we're looking at 2, 1, 2, 1. Okay, as our balancing there. All right, if they have the MgMnO4 first, that's fine, and the KOH second. I don't care what order those compounds go in. Okay, questions on number 6? All right, so, and again, guys, I put those in there because I want to make sure everyone remembers all those little rules, okay, because they're all important. Okay, number 7, we got to predict the products and balance the reaction below. It's a double replacement reaction. That's our first step in prediction. Okay, which means I'm simply going to swap the metals to make my 2 new ionic compounds. Calcium will end up with bromine. Iron will end up with chlorine. Okay, I have to swap and drop them both. Calcium's a +2 charge, so this will be CaBr2. Iron was a 3+ charge on this side, so this will be FeCl3. Okay, now I've got to balance the whole reaction. Lowest common multiple of 2 and 3 for bromine is 6, so a 2 there and a 3 there. Okay, that 3 needs to be balanced over here. 3 calciums, that gives me 6 chlorines. 2 there will balance the chlorines and the irons. Okay, and so you'll get 3, 2, 3, 2. Okay, you often see that alternating AB pattern. Okay, in double replacement reactions, quite often you'll see a 2-1, 2-1, or 3-2, 3-2. Okay, you see it fairly often. All right, so for this one, marks-wise, 1 mark for correctly predicting CaBr2, 1 mark for correctly predicting FeCl3, and 1 mark for having it balanced correctly. Okay, so it's out of 21. Give him a mark out of 21. Let him see it. Put it in a box. Okay, so on our first one here, again, first step in predicting the reactions is to identify the type. What type is going on in number 1? Combustion reaction. Okay, then we got to essentially just put in what we know are always the products. Okay, of a combustion reaction. That's just a memorization thing. Okay, then we got to apply both of the combustion naming rules because we got an even number of carbons. So we'll start with a 2. Okay, that gives me 16 carbons. 2 times 18 is 36, so 18 times 2 is 36. Okay, 16 times 2 oxygens is 32, plus 18 more, okay, is 50. All right, and that gives us then 25 oxygens there. All right. Okay, our second one. We've got an ionic compound reacting with another ionic compound. Nick, what would that be? Double replacement. All right, so in a double replacement reaction, I excuse me, simply swap the metals. All right, so I'm going to have Na ending up with oxygen and lithium ending up with phosphate. Okay, those are both ionic, so I got to swap and drop them. This is a -2, that's a +1, so I've got Na2O. Okay, and this is a -3 and a +1, so I got Li3, okay, PO4. Now I got to balance the whole reaction. Lowest common multiple of 2 and 3 is 6. So it's a 2 here will give me 6 sodiums. Okay, a 3 here will give me 6 sodiums. Okay, that 2 gives me 2 phosphates. So I need to go over here to get 2 phosphates, which gives me 6 lithium. Go back over here to get 6 lithium, and that happens to work out my oxygens, which I always leave for last. Okay, they're 3 and 3. All right, everybody with me there? All right, for number 3, I've got phosphorus reacting with calcium nitride. What kind of reaction is that, Devin? Single replacement. Okay, in a single replacement reaction, I have to swap the things that are alike. Phosphorus is a non-metal. So who is it going to replace? Nitrogen. All right, so that means nitrogen will end up by itself, and calcium will end up with phosphorus. All right, now, we said single replacement reaction, you're probably going to have to check everything. Special elements, swaps and drops, all that kind of stuff. Nitrogen is a special element, so it has to be a 2. Okay, this has to be swapped and dropped. This is a -3, that's a +2, so we're looking at Ca3 P2. Okay, then we can go back and start looking at balancing. Phosphorus is probably the thing I should balance first, as there's 4 over here. So a 2 there will help with that. That gives me 6 calciums, so a 2 here will take care of that, and then a 2 here will take care of my nitrogens. Everyone okay with that one? Questions? Okay, don't be afraid to ask as we're going through. Okay, number 4, I have a non-metal element reacting with a metal element. What's going to happen? Jay? Synthesis, yep, okay, synthesis reaction, and that's going to produce this compound. Remember I told you yesterday sometimes I'm mean and I do this to see how many people remember to put the metal first? Okay, does it make a difference? Yes, one's a properly written ionic compound, the other is not. Okay, so you got to make sure the metal comes first, because I might just do that to see if you remember. All right, now I got to balance the whole reaction. There's 2 chlorine over here, and there's 2 over there now. Okay, and then there has to be 2 potassium there. Okay, so little things like that. Okay, we got to be aware of. All right, number 5 only has 1 reactant, so that's a decomposition reaction. And in decomposition reactions, you almost always produce special nonmetal molecular elements. Okay, so sulfur and oxygen are both special molecular elements. Sulfur is very special, oxygen is only a little bit special. Okay, now what should I balance first? Sulfur is present in the largest number. I've got 8 over here, so I need 4 over here. That gives me 12 oxygens. 6 times 2 is 12. Okay, I should be good now. All right, then for number 6, I've got a metal element reacting with an ionic compound. Michael, what kind of reaction is that? Single replacement. Okay, so copper is going to replace who? Aiden? Okay, it'll end up with chloride, it'll replace lithium, yes. Okay, so Cu ends up with Cl, okay, and lithium ends up by itself. Now, did they give me any way to figure out what the charge on copper was in this reaction? They did not, so what do I have to do? Use the most common one. This is the only case where you just simply default to your periodic table and go 2 is listed first. Okay, 2 is listed first, right? Yeah, okay. All right, so CuCl2, then I got to go back and balance my lithiums and my chlorines. All right, if they give you a way to figure it out, like it's in the reactants with something, then you use the reactants to figure it out. But in this case, there was no way for us to know, so we have to go with the most common. Okay, for number 7, 2 ionic compounds. Larissa, it's what kind of reaction? Double replacement. Okay, that means iron is going to end up with permanganate, which is weird because I don't think that actually ever happens. Okay, and potassium ends up with sulfur. Okay, in this reaction, was I given a way to find out the charge on iron? Yes, I don't have to default to my periodic table. In this case, I look. All right, we'll get started on the lab tomorrow, guys. Okay, if I've got 1 compound, and then that's it as a reactant, that's what kind of a reaction? Decomposition. All right, so in decomposition reaction, I'm going to go down to the elements that made up that compound. So that's hydrogen and phosphorus. In a decomposition reaction, I often have to look for special elements. Are any of these special? Yeah, both of them are. Okay, hydrogen comes as a 2, and phosphorus comes as a 4. Which one should I balance first? Phosphorus, because it's present in the largest number. Okay, P4. Okay, so what do I need to put in front of this? A 4. Okay, how many hydrogen does that give me? 12. What times 2 will give me 12? 6. Okay, so now that one's balanced and done. All right, for number 9, I've got carbon and hydrogen reacting with oxygen, which is what kind of reaction? Combustion. Okay, so in a combustion reaction, we know the products are always CO2 and water. Do I need to apply the rule of 2 to this combustion reaction? No, because I have an odd number of carbons. So there's 5 carbons there. Now there are 5 over here. There are 12 hydrogens. 6 times 2 is 12. Okay, 5 times 2 oxygens is 10, plus 6 more is 16, and 8 times 2 is 16. All right, everybody with me there? All right, now number 8, element plus element gives what? Is a synthesis reaction. Okay, so that means that H and N are going to be together in a compound. It is going to be an ionic compound because hydrogen's listed first. It acts as a metal. So I have to drop and swap this compound. This is a -3. This is a +1. So I'm going to have H3N. All right. Lowest common multiple of 3 and 2 is 6. So I put a 2 here and a 3 there. Okay, and that'll balance everything. Now we're good. All right, so keep that stuff in mind, guys. Tomorrow we'll be getting our lab set up.